A general strategy for factoring a polynomial is to always first look for the greatest common factor and first factor out the GCF. If the polynomial has two terms, you have a binomial, you look for special cases like the difference of two squares, a squared minus b squared, which factors as a product of conjugates, a minus b times a plus b, or a plus b times a minus b. The two binomials have opposite signs. If the binomial is a sum of two cubes, there is a factoring formula you can use: a plus b times a squared minus ab plus b squared. Try to memorize this as a formula, and it'll be helpful to memorize the following sign pattern. If you start with a sum, start with a plus. In the factorization, the first sign is the same. So we're going to use S for same signs, plus to plus. The next sign is a minus. So we go from plus to minus. That's an opposite sign. So we use O for opposite. And the last sign is always a plus. So A for always and P for plus. And SOAP is an acronym and mnemonic or memory device to help remember this factoring formula. If the binomial is a difference of two cubes, a cubed minus b cubed, the factorization is a special product, a minus b times a squared plus ab plus b squared. So just like with the sum of cubes, the first signs are the same, minus to minus, so S for same signs. Then the next sign is plus, so the sign changes from minus to plus. Those are opposite signs, so O for opposite. And then always plus on the end for these two factoring formulas. Those two formulas end with a plus sign. If the polynomial has three terms, there's a trinomial. You look for special cases like a perfect square trinomial. We can abbreviate that PST for perfect square trinomial, where the first term is a perfect square, the third term is a perfect square, and the middle term contains plus 2. That can be factored as the product of two binomials. First term A, addition everywhere, second term B. So if you multiply, and you could use FOIL, you'll get a squared plus 2ab plus b squared. And that can be factored as the square of the sum a plus b. If the special pattern is a squared minus 2ab, so the middle term contains minus 2 plus b squared, that can be factored as the product, first term a, second term b, and the signs are minus minus. You can check that by multiplying with FOIL. You'll see that you get minus 2ab as the middle term and plus b squared. So a minus b times a minus b can be written as the square of the difference, a minus b. If you don't have those special cases, you can use the AC method or just trial and error, where you try a factorization, check it to see if it's correct, or you encounter an error. And you can check your factorization if it's the product of two binomials by doing FOIL to check your factorization. If the polynomial has 4 terms, then we try to factor by the grouping method. Let's do some examples. So let's factor problem 1, negative 3x plus 21, a binomial which is not any special pattern. We look for any common factors and factor out the greatest common factor. And by definition, greatest common factor is a positive quantity greater than 0, so we'd factor out positive 3. However, when the leading coefficient is negative, like in this case, the leading coefficient is negative 3, we're going to factor out a negative with the GCF of positive 3, and again, factor out a negative with the GCF and factor out negative 3. So equals negative 3, which distributes or multiplies times x, and negative 3 times a minus 7 will give plus 21. So check it by multiplying. Number 2, you want to note that the exponents on the variable are decreasing, so we have decreasing degree order, and we start with looking for common factors and the greatest common factor to factor out. So since 6 divides 36 and also 48 is a multiple of 6, we're going to factor out positive 6 as the GCF, but since the leading coefficient of the term of greatest degree has a negative coefficient, we're going to factor out negative 6 with x raised to its least exponent of x is a 1. So we're going to factor out the GCF, which includes x with the least exponent of 1, because only x to the first is common to all 3 terms. So factored out, outside of parenthesis, negative 6x times x squared minus 6x plus 8. Inside, we have a second degree trinomial. The leading coefficient now is a positive 1. So we're going to try and factor it further, where the greatest common factor inside the parentheses is a 1. Let's keep the negative 6 times x and see if we can factor the trinomial as a product of 2 binomials. First term is x, and we factor the constant 8 using either 1 times 8 or 8 times 1. Order won't matter if the leading coefficient is 1, but 8 is also 4 times 2 or 2 times 4. And the sign pattern inside the trinomial is plus 1 minus 6 and plus 8. So we say plus minus plus, which will factor into minus minus, but be sure to check it. The outer product, so O for outer, is going to be negative 2x, and the inner product is a negative 4x. And when you combine those two like terms, you get negative 6x, which is the correct middle term. And finally, the only common factor of the terms in the 2 binomials is 1. So the GCF is 1 for both binomials, so we know we're done. Number 3. We have 3 terms of trinomial. There's apparently no special pattern, so we start with the greatest common factor of the coefficients, 64, 40, and 96. So for the moment, avoiding mental math, if we prime factor 64, breaking it down using a factoring tree, eventually we'll see that 64 is 2 to the 6th power. So we're going to make a column of powers of 2 there. And then we'll go to 40. You can break that down as either 2 times 20 or 5 times 8. And let's go with 5 times 8. And 8 is 2 cubed. So underneath 64, we have 40 is 8, which is 2 to the 3rd, in a column with powers of 2, times 5. And 5 goes in its own column as a separate prime number factor. And let's make another column here. And then we break down the 96. It's an even number, so it's 2 times 48. And 48 is 2 times 24, and so on. Keep going with the factor tree. And that's going to be, let's show the 24. That's 8 times 3. Now, 8 is 2 to the 3rd, and there's 2 other 2s, so it's going to be 2 to the 5th power times 3. So let's go back to this method here. Write 96 as a product of powers of primes. So we have 2 to the 5th power, and 3 doesn't match with the 5 in the second column, so it's going to go in its own column. And now we look for the common factor, starting with 2, base 2. So the greatest common factor includes 2 with the least exponent, which is a 3. Only 2 cubed is common. 5 is not common, 3 is not common, so 2 cubed, which is 8, is part of the greatest common factor. But we also have to consider the x's and the y's now. So we're going to factor out 8 as a common factor, and x with its least exponent is a x to the 1st. Y is common, and the least exponent on y is a 2, so y squared. So by the distributive property, 8 times 8, 64, x to the 3rd, minus 8 times 5 is 40, x squared, y squared, plus, and then 96 divided by 8 is 12, x is factored out, so y cubed. So now we have to verify that inside the parentheses, the only common factor is 1. That's true, so we cannot factor further. And we have no special pattern, no special case inside the parentheses. In number 4, we have a product, 5c times, and a second product term, 3 times a binomial. In these two product terms, we have a common binomial factor, 3c minus 2. So we can factor out 3c minus 2 as the first step. So this is 3c minus 2, which is going to multiply and be distributed times 5c to make the first product. And then 3c minus 2 distributes and multiplies times a minus 3 to make the second product. The greatest common factor for both binomials is a 1, so we cannot factor any further. That is complete. Completely factored. Number 5. This is the sum of two product terms, and both product terms contain b plus 4 as a common factor. So we can factor out b plus 4 as the first step. B plus 4 in parentheses is going to distribute. And we're going to use a bracket here because the 5b plus 3 is in parentheses. So just not to have so many parentheses, we'll use a bracket. Then b plus 4 distributes, and we wanted to multiply 3b plus 1. Close paren, close bracket. Now, in this case, inside the brackets, all the parentheses don't make any difference, could be left out, and we're going to combine like terms inside of the brackets. So we have b plus 4. Let's go back to a paren. 5b plus 3b is 8b, and 3 plus 1 is 4. Now we have to check for common factors inside the parentheses. 8b and 4 have a common factor of 4, so we can factor out 4. So we have b plus 4 times 4 factored out times 2b plus 1. So that is a perfectly correct answer, but it's common to write the factor of 4 first on the far left times b plus 4 times 2b plus 1. Both binomials are prime polynomials, cannot be factored. In number 6, we have 4 terms, and when there are 4 terms, we try to factor by the grouping method. Now we're going to group 2 terms that have a common factor, and we could either group the first and second term, or the first term and the third term, or the first and last term. It just depends on the problem that you're given. In this example, we can group the first 2 terms because they have a common factor of 3y squared. And if we group the second pair, we have a common factor of positive 5. Keep in mind we have a minus in the middle. So by the grouping method, the grouping symbols we could use are parentheses. So let's group the 2 pairs. Now with minus in the middle, we have to be careful because when we insert and open up a parenthesis and the minus distributes, we need to change the minus on 15 into a plus so that when the minus in the middle is distributed, we get minus 15. Next up, we look for the greatest common factor for each binomial. The monomial that's common on the first pair is 3y with its least exponent, which is a 2, so 3y squared times y plus 3. We'll factor out a positive 5 from the second binomial and multiply it by y plus 3. Now y plus 3 is a common binomial factor that can be factored out. So we'll, in parentheses, multiply y plus 3 and distribute y plus 3 times 3y squared, and then y plus 3 times minus 5. We check and see if we can factor further by looking for a common factor for either binomial. Both binomials are prime. Their only common factor is 1, so we cannot factor any further. Number 7. Number 7 also has 4 terms, so we're going to try factoring by the grouping method. And since the first term and the second term do have common factors of 3 and x squared, we'll group those 2. And the second pair have common factors of 12, since 12 times 5 is 60. So 12 is a common factor, and so is x a common factor and the least exponent. on the second pair is a 1. So we'll factor out 12x to the 1. So in the grouping method, we'll use the grouping symbols. We could use parentheses and do the grouping steps. So 3x cubed plus 15x squared, close paren. Again, there's a minus here in the middle, so when you open a parenthesis, there's going to be a sign change, minus 60 into plus 60x. So now we're going to factor out the greatest common factor for each binomial pair. So we'll factor out 3x to the least power of 2 times x plus 5 minus positive 12 factored out. Let's factor out the x, 12x times x plus 5, close paren. So we have two product terms. They both contain x plus 5, so we can factor out x plus 5 as the common binomial factor. So x plus 5 is going to distribute and multiply times 3x squared to make the first product term in the line above. And then x plus 5 will distribute and multiply times minus 12 times x. We check and see if we can factor further. If either binomial has a common factor, 3x squared minus 12x has a common factor of 3x. So we need to factor out 3x to factor completely, factor fully. So we have x plus 5 times factoring out the 3x times x, and 3 times 4 is 12, and x minus 4 is prime. So commonly, the final answer will have the single factors 3x on the left, and then binomial factors following x plus 5 times x minus 4. Number 8. Number 8 is a second degree trinomial. It's in the special order of second degree term, linear term, constant last. Leading coefficient is a positive 1. We look for any common factors and factor out the greatest common factor, which is 1. Because it's a second degree trinomial, we see we can factor it as a product of two binomials. First term is x. Now the constant 28 can be factored in various ways and permutations, meaning we can change the order. But when we factor, the order won't matter if the leading coefficient is the one, which it is. So let's just talk about 2 times 14 and 4 times 7. And keep in mind the middle coefficient is 3. And 4 and 7 have a difference of 3. So 4 times 7 is 28. And now we mentally think of the correct signs or have a method and work it out. When you FOIL the outer product, so this is an O for outer product, is 7 times x. The inner terms, 4 times x. Now we have the like terms, 7x and 4x. The middle term is plus 3x, which we must get. So to get the required plus 3x, that tells us we need a plus 7 and subtract 4 to make plus 3x. So plus with the 7, minus with the 4, and the product will give a minus 28, so it is going to check out. Number 9. Number 9 is a second degree trinomial. The leading coefficient is negative 1. The greatest common factor is 1. When the leading coefficient is -1, it is good practice to first factor out a -1 or just a negative sign. And that will flip the signs of all the terms. So the +3 becomes minus 3p, and the +54 becomes minus 54. And the signs are flipped because on the outside is a -1 that is multiplying or being distributed. Next line, let's keep the -1 as a negative sign. The second degree trinomial inside is a GCF of 1, and it's a special case trinomial which may factor as a product of two binomials. First term, p, and 54 is 9 times 6, and the difference of 9 and 6 is 3. So here's a tool which may help. Sometimes it was called the X box method. We have a constant of -54, and the middle coefficient on line 2 is a -3. So this just helps you write out and see as you think of two integer factors of -54, which add to the middle coefficient of -3. And since 9 times 6 is 54, and we want a -3 as a sum, we need -9 and +6, whose product is -54. So we need a -9 and a +6. You can also just do in FOIL the outer product O and the inner product I, and you can figure out the signs that way as well. Number 10. We have a second degree trinomial. The greatest common factor across the three terms is 1. So let's begin by seeing whether or not we can express this as a product or factor, the trinomial, starting with 12r squared. Now 12 can be factored as 1 times 12, 2 times 6, 3 times 4. So let's try 3 times 4 first, or 4 times 3. And right now the order doesn't matter. 3r times 4r is 12r squared. Now we go to 15, -15. Let's just talk about 15 for now. So 15 can be factored as 1 times 15 or 15 times 1. The order is going to matter because we had 12 as a leading coefficient. So when you FOIL, the order is going to matter. We have 3 times 5 and 5 times 3. Now what's going to save us a little effort is that the greatest common factor is 1. So that means neither binomial can have a common factor other than 1. So that means we cannot have, when we factor 15, cannot factor it as 3 times 5, because then 3r and 3 would have a common factor of 3, but that would be a contradiction because in the beginning, the greatest common factor was a 1, and so it must remain a 1. It can't be a 3. The symbol for contradiction is a circle with an inscribed X. So that can't be. Therefore, we're going to strike out 3 times 5. And for that matter, we have to strike out 15 times 1 because we can't pair 15 with 3r because then it would be a common factor of 3. So let's strike 15 and 1. Furthermore, it may be that bigger numbers are not going to be in the factorization. It just depends on the size. How big is the middle coefficient? 11 is not that big. All right, so let's erase and ultimately try 5 and 3. 5 times 3 is 15. Now, in terms of the signs, we see that 15 is minus or negative, so we have to have opposite signs, a positive times a negative. So you can just figure it out that way. And you can also write down the outer product and the inner product. So let's do it that way. In the outer product, 3r times 3, that's O for outer, is 9r. The inner product is 5 times 4 is 20r. We must get the middle term of plus 11r. And we can get plus 11r if we have a plus 20r and subtract 9. To get plus 20r, we need a plus 5. And for minus 9, we need minus 3. Both binomials are prime, have no common factor other than 1. And to check, you could FOIL multiply. Number 11. Now, the new idea is we have two variables, x and y. Notice that the exponents on x are decreasing, the exponents on y are increasing. And that's a special ordering. If you're given a problem and the terms are scrambled, but you notice there's two variables, you want to reorder the terms and rewrite the expression. So you have this special pattern of decreasing exponents on x. So let's just do a little note. So on x, exponents are getting less and less, decreasing as indicated by the arrow. And on y, the exponents are increasing. The greatest common factor between 18, 37, and 20 is 1. 37's a prime number. The only factors of 37 are 1 in itself, 37. So the GCF is 1. X is not common, and Y is not common all the way across. Because we have a trinomial of this special form, we're going to try to factor it as a product of two binomials, starting with 18. 18 is 1 times 18, 18 times 1, 2 times 9, 3 times 6. So let's first try in this trial and error method, 3 times 6, or 3x times 6x. Now we go to 20. Now order does matter, because when you FOIL, you get different results when you change the order when the leading coefficient is not 1, it's 18. So we have 1 times 20, 20 times 1, 2 times 10, 10 times 2, 4 times 5, 5 times 4. And that could be a lot of possibilities, but we have the greatest common factor is 1. So we have to maintain that and not have a contradiction. So that means we can exclude certain of these cases, like having 2 times 10, because 6 and 10 would have a common factor of 2, and that would be a contradiction. That can't be, so let's strike out 2 times 10 and erase 2 and 10. Can't be 5 times 4, because if you pair 4 with 6, common factor would be 2. So let's strike out 5 times 4 and erase 5 times 4. Y, we need a y in there as well to make y squared, 20y squared. Let's strike 10 times 2, because we can't pair 6 with 2. There'd be a common factor of 2. And let's erase that. Before going any further, let's put the y in there before we forget them. Y times y will make y squared. All right, so we're at trying 4 times 5. Let's try 4y times 5y. Okay, the greatest common factor is 1 for both binomials. Let's check the outer product O and the inner product I. Outer product 3 times 5 is 15xy. Inner product 4 times 6 is 24xy. Now, we could add 15 and 24. That would make 39, but that's not the correct middle term of 37. So that won't work. And we can't switch 4 and 5 because we already crossed off 5 and 4. So that's not going to work. And let's cross out 1 and 20 because we can't have 20 paired with 6 because then there'd be a common factor of 2. So that's out. So we've exhausted the possible pairs of factors of 20. Let's put a check mark by 3 times 6. We tried everything, or just cross it out. Now I have to try 2 times 9 as a product. That makes 18. Let's erase 3 and 6 and try 2 times 9. So 2x times 9x. That works out. That's 18x squared. And let's see what we can cross out and eliminate on the pairs of factors of 20, if any. Let's switch to red here. So on factoring 20y squared, we have to cross out 4 times 5 because we can't pair 4 with 2. There'll be a common factor of 2, so that's out. So let's erase the 4. Let's strike 10 times 2 in red because we can't pair 10 with 2. So that's out. Let's erase it. We can't have 2 times 10. Same reasons. Because we'd have a common factor of 2. So 2 times 10 is out. Let's erase that. Can't have 20 times 1. Strike that. That's not a possibility. So we're down to 5 and 4 to try next. So let's put a 5y times 4y and do the outer and inner products. Outer product, 2 times 4 is 8 times xy. The inner product is 5 times 9 is 45 xy. We must get plus 37 xy as the middle term, which we can do with a plus 45 subtract 8. So to make plus 45, we need plus with 5y, and we need a minus with 4y to make minus 8xy, and verify that when you FOIL, you do get minus 20y squared. So that checks, and check that the greatest common factor for both binomials is 1, so we cannot factor any further, and that will be our final answer.